In the last video, we started looking at precipitation reactions and determining what precipitate, if any, would form. Now, the way that we were practicing writing the equation last time was called a formula equation. A formula equation shows both of the reactants, and it shows their complete molecular or ionic formula. It shows both of our products, and again, it shows the complete formula. But that's not the only way that we can write out our precipitation reactions. We can also write the complete ionic equation. Now, the complete ionic equation breaks everything into ions. So, if I looked at K2Cr2O4, that breaks up into potassium, and here's my polyatomic dichromate ion. Okay. Now, I've got 2 potassiums. I've got 1 dichromate. Now, it's important for me to keep track of the charges because it's the complete ionic equation. Potassium is an alkali metal with a +1 charge. Dichromate is a -2 polyatomic ion. Now, both of these ions started out aqueous, which means they dissolved in water, which is why I'm able to break them into bits. Barium nitrate, again, is going to break into barium and nitrate. Barium has a +2 charge. Nitrate has a -1 charge, and I have 2 of them. Both of these as well started out as aqueous, which is why I'm able to break them apart, because they dissolved in water and broke apart. Now, this is where it gets different. My barium, this should be Cr2O4. This is a solid. Because it is a solid, it does not dissolve. So since it doesn't dissolve, I keep it all together and write it exactly as it appears here. Because it's a solid, I leave it alone. This one's aqueous, so again, I'm going to break it up. It's going to be K and NO3. I keep track of charges. K is a +1, NO3 is a -1, and I have 2 Ks and 2 NO3s. Both of these started life as aqueous, which is why I was able to break them apart, because they dissolved. Now, in the complete ionic equation, it's very important that I show not only all of the ions, but their charges, the number of them, and their states. Okay? So the complete ionic equation shows everything that breaks apart into ions. Now, the complete ionic equation is actually usually not what we're going to write. We're either going to write the formula equation or the net ionic equation. However, to write the net ionic equation, we usually need to know how to write the complete. Now, the net ionic equation takes into account something called spectator ions. Spectator ions are ions that do not directly react in the reaction. They don't change. Let's change this. It should be participate. Same difference, but let's make our grammar good. So they don't directly participate in the reaction, they don't react, they don't change, so they look exactly the same as they do in the reactant side as they do in the product side. So for example, potassium is a +1, it's aqueous, there are 2 of them. Over here, potassium is a +1, there are 2 of them, and it's aqueous. So it did not change. It's still floating around as a +1 ion. It is a spectator ion. Here, I've got 2 NO3s. They're a -1. They're aqueous. On the product side, I also have two NO3s that are negative and are aqueous. So nitrates are also spectator ions. My complete net ionic equation would only show the ions that change, the ions I needed to form my solid. Now, by convention, we usually write the cation first. So Ba2 plus aqueous is reacting with Cr2O4 2 minus aqueous, and that is forming my solid. So the net ionic equation is showing the ions that actually reacted, that changed, that are precipitating out to form my solid. Okay, so it's important to remember we've got three types. Formula equation is going to show everything overall. It's not actually telling us what changed in terms of ions. The complete ionic equation shows us everything as ions if it's aqueous and everything that broke apart. Okay? The net ionic equation takes out the spectator ions that don't change, and it only shows us the ones that do. So here we're going to write some equations, and they give us our equations in words. I'm going to write the formula equation, I'm going to write the complete ionic equation, and I'm going to write the net ionic equation. So I'm going to go ahead and label these F for formula. Okay? So I've got aqueous potassium chloride. Potassium is K, chloride is Cl. Because it's an ionic compound, I need to check and make sure that my charges are balanced. K is a +1 alkali metal. Cl is a -1 halogen. +1 -1, this is okay. This is starting out aqueous. It's reacting with aqueous silver nitrate. Silver is Ag. Nitrate is NO3. Again, I need to make sure, because it's ionic, the charge is balanced. I know NO3 is a polyatomic ion with a -1 charge. Now silver, even though it's a transition metal, we learned in our previous lab that silver is always a +1 charge. So +1 -1, I'm good. And again, that was aqueous. They tell me it's going to form, there's my arrow, silver chloride, AgCl. Ag was a +1, Cl was a -1. It is my precipitate, so it's a solid. And aqueous potassium nitrate. Potassium nitrate. K was a +1, NO3 was a -1, 1 and 1. They go together, and it told me it was aqueous. So the formula has everything written out the way it would appear. The complete ionic equation, I'm going to label this C for complete. I need to break up anything that's aqueous. So KCl breaks into K and Cl. I'm keeping track of their charges. They're both aqueous. AgNO3 is aqueous, so I also break that apart. Whoops. Again, Ag was a +1, NO3 is a -1. I keep track of charges. I keep track of states. It forms AgCl. Because that's a solid, I leave it together. KNO3 is aqueous, so I break it apart. I keep track of their charges. I keep track of their states. Okay? So now I need to write the net ionic equation. In the net ionic equation, I get rid of my spectator ions. Well, K was a +1 aqueous. It's still a +1 aqueous. It didn't change. It's a spectator. NO3 is a -1 aqueous. Still a -1 aqueous. It's a spectator. It didn't change. The only things I care about are Ag +1. I start with my positive by convention. It's aqueous. Reacting with, oh, that's a mistake. Cl was a -1. My fault. Cl -1, which was also aqueous. And it's going to form AgCl solid. Formula, complete ionic, net ionic. Okay? So take a second and try to solve example B. Make sure you're keeping track of charges because the charges won't all be +1 here. In this case, I've got potassium hydroxide. So for my formula, K is going to be a +1 alkali metal, hydroxide, polyatomic ion, OH -1. It's aqueous. Aqueous iron 3 nitrate. This is the one that makes the charges different. They tell me iron is a +3. It's partnering up with nitrate, which is a -1. So Fe3 plus NO3 -1, I need to switch charges. The 1 comes over here, the 3 comes over here. So Fe1, NO3, 3. I need parentheses, and I need to show that it's aqueous. Okay. It's going to form a precipitate of iron 3 hydroxide. So iron is still a +3. OH is still a -1. So Fe3 plus OH -1, just like I did before. I switch charges. 1 Fe, 3 OHs. Don't forget your parentheses. OH is still a polyatomic ion. Okay? It is going to be my precipitate, so it's my solid, plus aqueous potassium nitrate. Potassium's a +1, nitrate's a -1, so they just squish together and they're aqueous. I need to balance it. Okay? So I started with 3 nitrates here, so I need 3 nitrates here. That gives me 3 Ks, so I need 3 Ks. That gives me 3 OHs. Oh look, I've got 3 OHs. Okay? When I write the net ionic equation, I'm going to break up everything aqueous. So K and OH are both aqueous. I keep track of their charge, and I add 3 of each of them. Fe and NO3 are both aqueous. I keep track of their charges, and I had 3 NO3s. FeOH3 is a solid, so I leave it together. And then, because this one's aqueous, I break it apart into K and NO3. K is a +1, NO3 is a -1, and I have 3 of each of them. They both are aqueous. Okay. So for the the net ionic, I have to get rid of spectators. K is a +1 here, aqueous. K is a +1 here, aqueous. NO3 is a -1 here, aqueous. It's a -1 here, aqueous. So for my net ionic, oops, sorry, this should have been complete. This is my net. I've got, starting with my positive, Fe3 plus aqueous plus 3OH minus aqueous, forming FeOH3 solid. Okay?